what's happening inside. But for Python, it is interpreted language, which means that it is executed one by one, means line by line, and which means that it has a huge amount of cost for interpretation. Whatever you write, it has to interpret it on the fly, and then it takes a lot of time to give you the result compared to C++. And so it already has has typically slower execution. But the main advantage of it is that since we are all beginners, for beginners it's extremely user friendly. So if you open up a Python console and if you just write 6 plus 2, it will give you 8. That is how easy it is. So you can even use it for as a calculator. So these are some major differences between C++ and Python, and the most major being that C++ is a compiled language and Python is an interpreted language. So I don't want to get into theory and all that stuff because we want to make this as hands-on as possible. But if you have any doubts, let's say if some more fact details you want about all these, then you can ask me and we can discuss it later on. Okay, so if you have any questions in between, please interrupt me, and I'll stop then and there, and then we can sort out the doubt, and then we can proceed. Right. Also, one more thing is that this might also feel the entire workshop because it's cramped within 2 hours. It might also feel that it's a lot to take at once. So if you are also feeling like that, so what you should do is that you should ask me to stop. We'll stop and we will take few steps back and we'll try to gather what we have discussed till now, so that you don't feel that I'm okay, I'm already left behind and I don't find it interesting anymore. Okay, so yeah, so that was for the slides, and I'll just quickly dive into the notebooks that I had prepared. So first question. So has everybody installed Python in their uh, desktop or laptop? Hello. If someone has not, please let's say raise your hand so that I can understand. So Anuj, you have not been able to install Python, or others are there? Prathamesh. Okay, so can you quickly unmute yourself and say what are the troubles you are facing so that we can quickly sort them out? You can write in chat also if you are not able to unmute or. Hello. Uh, See, if you are not able to install Python,
Just
but I'll say,
just 1 minute,
yes.
sir. I am enabling mic.
Okay, 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 okay.
Hello, sir.
Hello. Yeah.
Uh, just for you, I mean, just want to like confirm, like, are you able to see all these reactions and the hands and the chat notification while you are sharing your screen? Just
No,
for
no.
clear interaction.
No, I'm not able to see that. Means when I am looking at my notebook, I am not able to see what is happening. Maybe I should open notification or something. Uh,
Okay, okay, don't worry. We'll let you know.
it's better if you interrupt me because it's very hard to go back and forth. Any
Huh.
issues? If you see your friends are raising some issues, you just interrupt me and I'll just stop.
Yeah. Okay.
Okay. So
Yeah.
if you don't have issues with installing Python, then we can move forward with the notebook part. It will be great if you can open up a notebook on your own, Jupyter notebook on your own. And so I already asked Harshil or Vaishnavi, I don't remember. I asked them to convey the message that you should install Python, Jupyter notebook, NumPy, and Matplotlib, which we will use throughout this workshop. So if you have installed it, it's fine. If you have not installed it, then it's also fine. There are alternatives to Jupyter Notebook if it is not working. What you can do is that you can go to Google Colab, and here you can just use your Google account to sign up and open Jupyter Notebooks like this new notebook. So I don't think you sign in. You have to sign in. So I'll use. So I'm using my Google account to sign in, and it should allow you to create a Jupyter notebook, the same which I am using now. Yeah, so it has already created the account. What you should do is that connect to a runtime. Here you should ask connect, and once it's connected, you are good to go. If I write print hello world, once the connection is done, it should work like Jupyter itself. So this is for if anybody is not able to get Jupyter notebook working, you should use this. Okay, and if you can work with a Jupyter notebook, it's fine. So now it is connected, and what you need to do is that just run print hello world, and it will do everything hello world, right? So this is the Jupyter notebook you can use. If you don't, so you don't need to even install Python and all that. It's all there. Okay, it's all there. In the internet, you can just get started with it. So yeah, so based on the response, then I'm going ahead with the basics of Python. So first, what I'll do is that I'll just go over the data types. So this is the most important and pretty most basic thing that we need to learn if we are going to learn any programming language. So Python has 4 primitive data types. So primitive means these are the most basic and contain very simple and single piece of data. So the primitive data types are called integer, float, int, and boolean. So here I have examples for all 4 of them. So integer, let us consider a number num equals to 5 as shown here. This is an integer type data because it's a complete natural number, right? It does not have any decimal point or anything ahead of the decimal point. So it's just an integer. And if you use this function in Python, which is called type. So type function, what it allows you to do is that it allows you to ascertain the type of any object that you send, object or variable, whichever terminology you are familiar with. So num is an object in this case, and we have assigned num a value, integer value of 5. And if we ask Python, tell me what's the type of num, it tells int. So int is the notation used by Python to say that, okay, this object, whatever you have given to me, is of integer type. Now float. So float, what is float? So float typically have decimal point precision, and after this you can have as many as numbers. So the thing is that if you add uh, decimal and you don't add any more non-zero numbers ahead, 5.0 maybe. So 5.0 is mathematically same as 5, but the data type here is float because you have added that floating point or the decimal point. So if I run this, you see it first says that for the first cell it's integer, and for this cell it's float. So yeah, so these are the two types of data that we mostly use for calculation. These are the most common data types if you use for calculation. Uh, then there is another thing that you can do is that, so let's say I give you a floating point number. Okay, so let us consider this number 5.42. Now you can ask Python to forcefully convert this floating point number to an integer type number. Okay, so if, what happens if you try to do that? So how to do that? What you do is that you call this function which is called int, and inside this parenthesis what you just put is int and the floating point number. If you put this, what you see is that it has omitted everything after decimal, and it will give you only things which are present at left side of the decimal. So if you give it 5.42 in integer under parenthesis, the floating point number will just delete everything which is ahead of the decimal point. This process is called typecasting, which I have written in the notebook. So don't worry, I'll talk with the organizer so that all these notebooks can be shared with you and you can play around later. But the concept is this. So if you want to convert a floating point number to an integer, you will lose all the data, all the information which is right to the decimal point. Yeah. So floats also have something called precision, and we will discuss later in the sense that it is not very necessary in a basic Python course. So it's more of an advanced treatment. But if you are interested in knowing about, then we can uh, talk about this after all the notebooks, after we cover all the notebooks that I have prepared. Yes. So then what is the third type of data type? So the third type of data type is probably the most primitive and most simple, which is called Boolean. Boolean data, what it does is that it can store only two values, either true or false. And in computer language, you can think of it as 1 and 0. So 1 means true and false means 0. And computer only understands this language. So whatever we write here in Python or any language, it is being translated to 1000, a series of 1 and 0, which the computer can understand. So here, this is most primitive because it can only give you two types of results, either true or false. So true is written as capital T followed by RUE. This is a keyword in Python. So don't name your variables as capital T RUE. So it's a keyword. It's something which is reserved for Python. So similarly, you can also write false as capital FALS, and it's a type called bool. Okay, so Boolean is noted as bool in Python. So the next data type, that is something that we probably don't use much for scientific computing as such, but it is very useful to know because, yeah, maybe it is very useful if you want to write a application, develop a software, because you need to give names, check names, and blah blah all that. So for that we use strings. So strings, what they do is that they contain series of characters one after another, and this series of character together is known as strings. So to write a string in Python, how you should write is always put it inside either double quote or single quote, like this, AZeotropy, either double quotes or single quotes. So this is the data type which is known as string. And if you ask Python what is the type, it will give you str. So str is the string shorthand for Python. String shorthand in Python. Yeah. So there are some fun string functions that already come inbuilt with Python, which you can play around with. So I have given some examples here, and more details you can find here in this link. So what you have to do is just click this link and it will take you to some website. So more or less, I have tried to do wherever I can add these resources, I have added. So see, so some string functions I have already added here. So name, whatever is the string object that you have uh, named it. So this is something I have said. Name is the name string object, and this name has some functions which are attached to it. Means name has some things under the hood which we can see directly, but we can call them up to do something for us. So name, if you write name dot capitalize, you see that what it does is that it just converts the first letter of the word to uppercase. So it was small a zeotropy, now it's capital A zeotropy. Similarly, what we can do is that we can convert all the letters in this string to uppercase. So what we can do is that say name dot upper. This means that all of them have gone to uppercase. There are other functions, but one very fun function is that, let's say you have azeotropy and you want to find what is the first, where is the first occurrence of O. So if you say name dot find O, it will say that it occurs at a position 3. Now position in Python is written as, so this A is at 0th position, this Z is at first position, E is at second position, and O is at third position. So it always starts from 0, 1, 2, 3, 4, and on. So if let's say I say that we want to go to the 6th position, means if you want to find the 6th letter, can you tell me what will be the position of that letter in Python terms? Anybody? Let's say we want to find the 6th letter in this azeotropy, which is R. Okay, R. So can anybody tell me what this function will give the output as? Hello? Anybody, you can just unmute and tell if you are allowed to. I don't know if you are allowed to.
Yes, yes, everyone is there.
So can anybody just quickly unmute and tell me what should be the output of this function? So you just count. So O is at first, second, third, fourth position, right? And it gives us an output of 3, which means for nth letter, it always gives you n minus 1. So if we are looking for R, where n is equals to 6, n minus 1 is 5. So name dot find R should give you 5. 5. Okay, clear. So this is what you can do with strings. So strings are pretty fun to work with, and if you are sitting for any companies which work with, let's say, some IT companies which have some IT front end, back end, whatever, in that case, you can expect that in the test they will ask you some string manipulation using Python. If you are choosing Python, they will ask you some string manipulation. There are usually 1-2 questions on that. Okay. So this was about the data types. Now there are few more things that we need to go through before we can delve into let's say some meaningful code in Python. So for that, first thing is that we should know how to print data to console. So wherever you see I am not storing this data into any variable, right? If let's say I want to store this data into some variable, you'll see that it will not show you 5 again. So let's run this. See, it did not give any data, any output rather, because we have stored that output in this variable and we have not asked Python explicitly, okay, show me what did you store there. So if you write scripts, if you write Python scripts, so we are doing this in Jupyter Notebook. If you write it in Python scripts and if you have a long code, you don't want to print everything, right? You want to store data inside some variables. And later on, what you will do is that you will print those data again to the whatever data the user wants to see, will just print out so that they can see and understand whatever the output is from the code. How to do that? How to show the user some specific data? For that, what we should do is that we should use this function known as print. So let's say I assign some value to num, which is num equals to 5. And if I write print parenthesis num, you see that it prints 5. So then this should work here as well. If we say print ing, it should give you, now show you 5. Let's run. See, it showed you 5, which means that print command is the one that allows us to uh, show some data or output some data to the console. You can also add multiple things inside the print statement separated with a comma. So if you write num equals to 5 and you write print, the number is comma space num, then it will give you the number is 5. So see, automatically adding this already adds a space here, right? So if you add an extra blank space, it will just give you 2 spaces. See, it just gives you 2 spaces. Now, one more thing that we can discuss is that what happens if we have 2 consecutive print statements. Let us say hello and let us say world. So what will happen? Let us see. So you see that one print statement always prints in one line. So after that, there is automatically a line break, which tells that, okay, after you have come here at the end of the print statement, you should go to the next line and then execute the next step. So that is why you see that hello and world are in separate lines. But the question is, what if we want hello and world to be in the same line? But I don't want to write it together. So I don't want to write this. I don't want to write this. I want the code to be like this itself, that these statements are in different lines, but I want them to appear one after another. So world should appear here. So for that, what we can do is that we can write this end. So by default, at end, what it does, it adds a next line. But here we are saying that don't add next line. At the end, just add an empty string. This means an empty string, which is basically nothing. Nothing. Just not a next line. It's nothing, which means that it has no value or stuff. It's just an empty string. And now what will happen is that, see, it came together. But it doesn't look good, right? See, it is clumsy. Hello and world are not separated. It's one after another. So what we can do is that we can just explicitly add a space bar here. Means a blank space here. And it should work like this. Understood? So this is how you can play around with print statement. This is enough for the basics part. Like for advanced, we have some uh, other things that print statement can do, but that is something which is not required to get started with Python. So another thing is escape sequences. So you remember I told that the print automatically adds a new line or a line break. Now how does this line break look? Can we add this by ourselves? Answer is yes. So the line break is a special character like this, which is preceded by \n. So you see, if I write hello, I am adding a \n new line. You see that after a, whenever this \n is encountered, it breaks the line and takes the output to the next line. So it has added some extra space. So what we can do is that we can remove one space and it should come. Okay, so this is a special character. You can only use this when you want to break the line and go to the next one. If you just add it as it is, it will always break the line. So be careful. Do not add \n inside your print statement if you don't want to have a line break or something. So these special characters are also called escape sequences. So like we have a escape sequence to go to a new line, we also have an escape sequence to apply a longer space, which in computer terminology we call tab. Okay, so if you want to add a tab, you see you just add \t. So see, after a and before tab, you have a very long space, and this is much bigger than a single space. So if I don't add a space, it's just this. But if I add a tab, oh, it's so big. Okay. So these are the escape sequences which you might use if you want to print some data out for the user. And these things, all the things that I have discussed till now are very useful if you are going to data analysis or scientific computing as such. right? Anything which is relevant to chemical engineering, fluid mechanics, and all that. So, okay, so after the escape sequences, one of the most important thing that we have to learn is arithmetic operations. How to do arithmetic operations in Python, right? So there are 5 arithmetic operations. Okay, there are more, some more, few more special arithmetic operations which I'll discuss after this. So there are 5 primitive arithmetic operations. First one is addition, which is just given by this plus symbol. Then we have subtraction, which is given by minus symbol. So this should be slash. Then we have division, which is given by slash. Then we have multiplication, which is given by this star symbol or asterisk. And modulo is what is given as percentage. So I'll discuss what it does. So I don't think I need to explain addition. So if you have two numbers, num1 and num2, addition result will just be num1 plus num2. And if you run this, you can see 13 plus 4 is 7. Okay. Similarly, for difference between two numbers, you can do num1 minus num2, you have 9. For division, if you do 13 divided by 9, it will give you the exact division. Okay, it's a floating point number. So 13 is not divisible by 4. So it will not give you quotient or it will not give you the remainder. It will give you the exact floating point division. So if let's say it was not a truncated division, it will just keep on going. So for example, if you divide 20 by 3, what do we expect? We expect a very long 666 something. So see 6.66666. After some point, it will just round it off. Okay. So let's not do that and let us go back to 13 by 4. Now see if product is given as 13 multiplied by 4, which is 52. So these are pretty standard results, right? Something new for you might be modulo. What does modulo do? So if you are doing any division, so here we see that we saw that we got the exact floating point division. If you do number modulus number, what you will do is that it will perform the same division, but it will only give you the remainder from that division. So the remainder from this division is 1. So fourth is a 12, and then you subtract, you are left with 1, which gives you 1, right? 13 modulo 4 is 1. So you can check out with other numbers. You can just play around with all of this. Similarly, you should ask a question, but if I don't want a floating point division, I just want quotient. This is also very useful. It will come very handy later on. So let's say if you want the quotient from the division, you should force Python to do division in an integer fashion. So it should do the integer division and not the floating point division. An integer division is written as double slash. So if you do num1 slash num2, see, it does not give you 0.25 and blah blah. It will just give you the quotient, right? Another thing that I did not add here is power or exponent. So I'll just add it quickly. So for exponent, there is a shorthand notation. So let us call a number 2. Okay, we know what 2 square is, right? So 2 square will be print num multiplied by num. So 2 square will give you num multiplied num by into num is 4, right? But we can also do num 2. So these consecutive products or asterisk asterisk star star, what it does is that it makes this as the base and this as the exponent. So this is basically 2 square. 2 square. If you write it in this way, it should be 2 square. It is doing 2 square and it will give you 4. Right? For both the cases, it just gives you 4. See, it's 4. So similarly, what you can do is that for 13 and 4, you can just write print num1 raised to the power of num2. And see, it will just give you 13 to the power 4, which is blah, blah, blah. I don't want to check if it is correct or not, but let's have some faith in Python. So this is what it will do. And one funny thing about string is also, you can also add strings, right? If you add strings, what it will do is that it will crumble all these strings together and give you a final string. This process for adding string is also known as concatenation, which is written here, concatenation. Right. So if I have three strings, I love Python, and if you just add them like this, you have I love Python. Okay. If you want to add space in between, what you should do is that you can add explicitly spaces, and then it should look more nice. See, I love Python. Okay. Also I have already added spaces here. Yes. So this is about arithmetic operations or some string operations. And this is what we will mostly use, and mostly you will also use if you're doing scientific type of programming. Now the next thing is importing modules, right? So Python is a huge language. Okay. It has huge support base and everything. And if you go into Python's website, where they list all those things, you can see how many projects are there. 580,000 projects. Okay, so these many projects have some use case for everybody, right? So how do you use this 580,255 projects? You install them in your PC using something known as pip install. So I guess if you don't know, we can discuss it later on. So there is some command. So if you go to any package and you just write pip install, then it will install this package onto your computer. And if this package is installed in your computer, what you should do, what you can do is that you can import that package into your current program so that you can use functions from that package. So one inbuilt package is called math, which gives you the math functions, obviously, and you can just use import math to import the math functions. And I have here used one of the very common math functions, which is called sine. So what you do is that you tell the math, you call the module you want to use, you say math dot means whatever is inside that math, you are searching for a function there. What is the function you are searching for? You are searching for sine, and you just put angle, and see that angle is given in radians. So if you just put angle in radians, it will give you whatever data you apply. So this is 0.5. So sine of 30 degree is 1 by 2, which is also 0.5. So for more math functions, if you want to look at and play around with, you should click this link when you get the notebook, right? So every notebook has some area known as playground. In this playground, what you can do is that whatever we discuss here, you can play around with this. Okay. So I hope you are also going, typing some of the things and seeing that if what I'm telling is true, I'm not like scamming or something, right? So you can also write on your own and just check if something works or if something does not work. If something does not work, please stop me and ask me questions, doubts, and clear out all your doubts here. Okay. So this was all about basics, right? Basics means things that we can't proceed without, like data types, arithmetic operations, printing to console, and importing models, right? So if you have any doubt in this notebook, you can ask me now. So I'll stop for a minute or so. So don't write in the chat because I am not able to view the chat. But if you have any doubt, you can just go on unmute and ask. I was audible all the time, right, Harshil?
Yes, yes, sir.
Okay. Okay, so I'll assume that you don't have any doubts and these things are clear to you. So then we will move on to the next part. So the next part is uh, flow control. So last in the last notebook, what we were discussing were very simple things. That we just write one line of program and it does the job and it just gives us some result, right? But now what we want to do is that we want to control the flow of our program. We want to see how we want to control which line the program should execute and which line should not. It should not. And if it wants to execute some line, is there any condition under which it should execute, or is there some condition under which it should not execute that line? Right. So this entire thing is called flow control, and this flow control is typically done by conditional statements or loop statements. Right. So either you add some condition to a certain block of code and ask it that, okay, if this condition is satisfied, do this or do that. And for loop statements, what you do is that you ask the code to do certain tasks repeatedly for a given number of time. Okay. So for flow control statements, I have chosen the most useful statements that is there out there in Python, right? Or maybe other languages also should have this. So first, for conditional statement, we will only go through if-else statement, because other cases like switch case, I have not used. I have not seen people use that much. It is useful, but most of the times we just use if and else, right? So let us consider if and else statement here. If you want to learn about switch case statement, you can go to Python documentation. You can learn. It's pretty easy and pretty straightforward. So for if-else statement, see if you have. So the basic syntax is something like this. So it is basically used to branch the code into two or more different paths based on some condition. And what it will help you is that you can control the outcome based on those conditions, right? So this typical syntax is if space whatever condition you want to put. Yes. Uh, Anybody wants to ask something on? Okay, fine. So after if you put a space and then you set condition, and then this colon is must, right? This colon, without this colon you will get a syntax error. And after that what you have to do is that you have to perform an indentation, right? So this indentation, what it does, indentation means you add a specific number of spaces. Usually tab should do the job. So if you put tab, you will see that it is to the right of whatever if condition you are putting. So this indentation, what it tells is that, okay, this line should be inside this if condition. Okay. If you don't do this indentation, it will treat as if this line was not inside this if condition. So if the condition is satisfied, then it will do something. Then you can add more conditions. How? By saying else if. Else if is combined in Python called as and known as elif. So elif some condition, then you do something, and then you can have multiple condition, and at the end you can have an else condition, and then you say if none of the conditions are satisfied, then do this, right? So typically you can also write a program without else statement, but this is a typical syntax, right? And to illustrate it, I illustrate this, I have used a very simple example. So what you will do is that we can do is that use the if and else condition to check if a number is even or odd. So this is very straightforward, right? To get a number is even or odd, you just divide it by 2 and see if it is divisible or not divisible. So you remember that we went through the modulo operator. So if a number is divisible, then modulo operator should give us 0 because it returns the remainder. But if the modulo operator does not return 0, then it means it is not divisible. So what we will do is that num equals to 11. Let us consider a number 11, which you can see already odd. And we say that if num, and we see that if num modulo 2 is equals to 0, then you print that num is even. And if this condition is not satisfied, then you say else print num is odd. So what we will do is that we will just run this cell and see 11 is odd. And this should work for any number, whatever number I gave, and we'll say this is even. So this works, right? This is how you can control what line should be executed, which of the print statement should be executed. It is also possible to write if else statements inside another if else statement, right? So here we have a nested if else. So this process is called nesting. So in this nested if else, what you can do is that, see, animal equals to true. I have just randomly added few variables. Type of animal is dog. And now the condition is if animal is true, then you go inside and check if type animal is equals to dog, then print animal is dog. Else print animal is not dog. Right? So if it prints that else print animal is not dog, it means that it went here, satisfied this condition, but failed to satisfy this condition, and then came to the else part and executed this. But in this case, what will happen is that it will enter here, satisfy the condition, it will satisfy this condition, and it will print that animal is dog. And if animal is not true, then it will just say that not an animal, right? So what do you expect the output should be here? So the output should be here, animal is dog, and it gives you the output. So we can also play around with this, just say false, and what we should find is not an animal. Now if we add, what happens if we add cat here? Can anybody tell what should be the output again? Anybody? What should be the output here? Hello. This is fairly simple. So yeah, anybody was going to tell, or hello?
Same, not an element because the condition of if animal is true.
Yeah, correct. So because this condition is still false, it will always go here. So we can just verify. Yeah. But if I do this true, then it should give us this line. Animal is not wrong. Right. So this is a very simple primitive example of nested if else. And when you want to use, why you want to use, it's completely up. Right. So there are also very large problems when you are having multiple if else statements, nested if else statement. What it does is that it makes your code execution slow. But that is not a basic problem, right? This is something an advanced programmer should deal with, right? So for the moment, these are the capabilities that you can do. And I hope that you learned C or something in your first year in BTech, right? So you already know some of these statements in the context of C or C++. Just that in Python, the syntax is a bit different and probably a bit easy. So you just write if it's true, you don't have to add braces or something. Just put a tab here. Just put a tab and it should align. It should give some indentation and it should work out. Okay. So what I want you to do now is check, write an if else condition to check whether a number is positive, negative, or zero. And let us consider that number to be -4. So this should take 2-3 minutes. So quickly, can you write down a simple if else statement to check if a number is positive, negative, or zero? The question is fine, right? Means you have understood the question, right? So if you have any doubt with the question, you can just quickly ask, or else just see if you can write this. Should be pretty straightforward.
Can you please repeat the question then?
Huh? Excuse me?
Please repeat the question then.
So the question is that given a number which is -4, can you write an if else statement to check whether this number is positive, negative, or zero? So could everybody write it? Or are you facing any trouble?
Okay, you guys are are allowed to unmute and answer. And if you are facing any problems, you can raise your hands.
So if somebody has done it, then you can just raise your hand. I guess that will be fine. So Aditya has raised hand. And Harita, I guess. So it means you were able to do it, right? Haseen also.
Because if you have problems, you can unmute and ask one by one.
So if you have problems, just straightforward ask. If you are done, then you can just raise your hand. Okay, so many people were able to do, I guess. Great. So in the interest of time, we have to continue. But what I'll do is that I'll quickly show the solution so that you can later on do this. So I have already made all these solutions. Maybe. So the number I said was -4. So the condition should be just if number is greater than 0, then print num is positive. Elif number equals to 0, then print num is 0. If and else if all of these conditions are not satisfied, then just print num is negative. Okay, and just run this and it will say -4 is negative. So it may be that you are writing something else in the print statement, or the variable names is different. That I don't. That is not something you should be bothered with. Right? What should happen is that given a number, it should properly tell is it greater than 0, less than 0, or 0. So this is the solution for a very simple case. And what so once yes.
Sequences of conditions can be anywhere. Like we can also first check like sequences you check for positive first, then we can also check for negative first and then 0 and
Yes. The conditions can be put in any sequence. Doesn't matter. But what happens is that Python reads these conditions, means program line by line. So what it will first read, num equals to -4. Okay, so then it will say you are num and you should hold the value -4. Then it will go to if num greater than 0, and it will see that, oh, this condition is not satisfied. I'll go to elif. Then it will say elif num equal to 0. So equal to is used to, right? If something, if it is used to check that if something at the left hand side is equal to something at the right hand side or not. Okay, so it will check whether it is 0 or not. Then it will say, okay, it's not satisfying the condition. I'll go to the else part, and at the else part there is no condition, right? So whatever was there, it will just execute. Understood? So you can just put any conditions, first, second, third, doesn't matter. Sequence can be anything. Point is, if you put any number, it should give you whether it's positive, negative, or 0. That is the only requirement that we have from you. code. Right. Clear? Any more doubts? Fine. So let us move into the next one. So the next flow control statement that we want to study is called for. It's a loop statement. It's called for loop. So for loop, when we use it, is if we want to execute a certain number, certain statements one after another for a certain number of times. So here consider this case. So what I am asking myself to do is that print all the natural numbers, which means the integers, from 0 to 4, which means it should print 0, 1, 2, 3, 4. Fine. So for this, what we do is that we write the syntax goes like this. So for, it's very English like, okay, the way we write English, it's very English like. So we just say for I in range 5. So range 5, what it does is that it creates the numbers one after another the way we have asked it. Okay, so if you ask range 5, what it will do, it will start from 0 and go up until 5 minus 1, 4. So any range n will always go from 0 and generates numbers up to n minus 1. Okay, so if we write for I in range 5, what it will do is that it will create all the numbers between, all the integers between uh, 0 and up to 4. So 0, 1, 2, 3, 4. So if I run this statement here, uh, cell, you see it just prints 0, 1, 2, 3, 4. Fine. So this is how you write a for loop. Now, what we should note here is that we are telling how many times the loop should run. It should run 5 times. And what it should do, it should generate whatever number was generated here, it should print it out. So this is the simplest possible way to do it. Now the next thing we can do is that we can play around with this range function. What we can ask is that, okay, we printed 0, 1, 2, 3, 4, 5. Now let us print it in reverse. 4, 3, 2, 1, 0. So for that, what we will do is that we will specify from where we want to start iterating. So we want to start iterating from 4, right? And then we how much we want to, how many numbers we want to go through, 5, right? So if you include 4 and go up to 5 integers, then count with me, it should be 4, 3, 2, 1, 0. So 0 is the 5th number, right? And we know that range always iterates up to numbers n minus 1. So if I put minus 1, then minus 1, sorry, the minus 1 number ahead of minus 1 will be 0. So you should give us numbers up till 0. And how, now the question is that if I'm going for 4 to minus 1, I need to say range that do you want to go forwards or do you want to go backwards? So if you want to go backwards, what you should do is you should you should subtract 1 from every numbers that you generate. So you will just do 4 minus 1, 3, 3 minus 1, 2, minus 1, 1, 1 minus 1, 0. So that is why here we are telling what is this step. So 4 minus 1 minus 1. And then we print all the numbers that are generated. And you see we get 4, 3, 2, 1, 0. Okay. So if you have any doubts up until here, right, for the for loop part, this range part there, because this might be a bit tricky for some people. So if you have doubt until here, please ask now. If you have any doubts up until here, please ask me. Okay, so I'll assume that you have understood as of now. And then what I'll do is that we will go to nested for statement. So similar to if and else, we can also have for loops inside for loops. So we can have for loops inside for loops, right? So if you have for loops inside for loops, a very simple test case to do this type of exercises is printing some patterns. Right? See, so I have made a right triangle here, which is made of asterisk, right? I want to print this in console. I want my program to behave in such a way that it gives me an output which looks like exactly like this. For that, what I can do is that I know that there are 5 numbers here, right? So which means that to generate 5 numbers, my range should run from 0 to 5. And for if I want to run from 0 to 5, what I should do is I should put range n should be 6, so that n minus 1 is 5. So what I do is that I write one loop here for I in range 6 and another loop inside for j in range I. So what happens is that for every time this loop runs, it will run here. How many times? I number of times. So every time I come to this line and get inside, I will run this entire thing, I number of times. So at first I will have a value 0. So it will just, sorry, at first I will have a value 0. So it will come here and then I will run from 0 to 0, right? Which means it should not run for at all. It should run at all. Then when I will be 1, right, I will enter. Then I will enter and then I'll have j run from 0 to 1, which means it will run one time. And if it runs one time, what it will do, it will print 1 star here, right? And after printing 1 star, I don't want to go to the next line directly, because every time what it will do, it will just print 1 star and go to the next line. I'll show you what is the problem with that. So, but I don't want it to go to the next line. I just want the cursor to stay here after printing. Then after this loop has finished executing, what I will do, I will just print. I'll just give a empty print statement. What it will do is that it will put the cursor to the next line. Now next time when I come here, I will have a value of 2. And when I will have I has a value of 2, it will run from 0 to 2, which means 0 to 1, which means 0 and 1 2 times, right? It will run 2 times and then it will print 2 stars. Here it will print 2 stars, and after that when I print, give an empty print statement, it should go to the next line. So let us run and see if it works or not. Yeah, so you can see that it has generated the exact pattern. Now the question is what happens if we don't add this end here. So you'll see that all these stars just come one after another in us. What means line after line. Okay, so we don't want that. We want this nice pattern to be printed out in the console. So for that, we will add this end statement and we'll just print. Now, one question you might also ask, what if I don't add this print? What will happen? See, it will print it in one single line, because now we have no condition which says that the cursor has to go to the next line. So to force the cursor to go to the next line, we need this print statement, which gives you this nice and beautiful pattern. So what I want you to do is that, so there are 2 examples that I have set, right? So in one example, so look at this code here. See how I have written it, and I hope you have understood, and try to write the same code for generating this pattern. Okay, so take maybe 5 minutes, take 5 minutes and generate a code that can print out this pattern. Did everybody answer, get the question, what I am asking you to do? If anybody it means if you are in any doubt, please tell now, or else you can just see if you can generate this pattern. So could anybody find a way to print this pattern? So if anybody is done with it, like just uh, raise your hand. And if you have any issues, you can just unmute and just tell. So this is not as straightforward as the last exercise. It was just very trivial. This is not very straightforward. Uh, so maybe I'll show the solution and you can look at this and play around with this later, because I'll not share the solution with you. So you can just write it on your own later on. So see, for printing this pattern, what you can do is that the outer loop remains the same because you have to go up till 5. For the inner loop, what you can do is that you can run a range up till whatever number you have here, subtract it from 5. And for this loop, you can only print spaces. Then you will see that you are only printing spaces before, right? And after this loop has finished executing, you print the write the exact same loop which was already there before. Then it will print 1 star and 4 spaces. Next time if you do, you will see that it will print 3 star, 3 spaces and 2 star. Then it will be 2 spaces, 3 star, 1 space, 4 stars, and later on 0 space and 5 stars. Right. So let's see if this works out or not. Yeah. See, so it can print the pattern. Right. Anybody who did not get the trick here, you can tell now. Hello. So you had someone got unmuted, but there was a huge background noise. So if anybody did not get the trick, you can unmute and tell. Okay, then let us move to the next example. So next example is a bit more trickier. Okay, so for the next example, we want to print this pyramid, right? So what I'll do is that I'll share these notebooks with you, and I don't want to give out the solutions as of now, but we are also running short on time. So I want to discuss a few more stuff. So maybe what you can do is that once I give this notebook to you, you can try this out and see if you are able to generate the solutions or not. So I'll not give you the solution because there are multiple ways to generate this pattern. This is not the only one way, and I want you to play around with this so that you learn a bit more about logic, how the logic runs inside the Python code. So I'll quickly, what I'll do is that I'll move on to the next part, which is the while loop. So we saw that for loop, what it does is that it iterates or it repeats a certain number of statement for a given number of times, right? You say how many number of times you want this thing to happen, how many number of times you want this statement to execute, right? While loop, what it does is that you use while loop if you don't know how many times you want to use it, how many more times you want it to run. But what you can do is that you can add some condition that if certain condition is satisfied, then the while loop will stop iterating. So it will stop the iteration and it will just come out of that looping part, and it will give you whatever it will execute whatever statements you have written after the while. So this is useful if you know the condition to stop, but if you don't know how many times you want to run, right? So let's say for an example, I have said that divide any number by 5 and print the quotient until the quotient becomes 0. Right. So this is what you need to do inside the while loop. You need to divide the number by 5 and print the quotient until the quotient, whatever you are getting at every iteration, goes to 0. Right. And now you have to remember that for getting an integer quotient, we must do the integer division, which is double slash. So I choose a random number 134, 234, whatever. And what I say that if means while number integer division of 5 is greater than 0, it is not equal to 0, but it is greater than 0, keep printing whatever this quotient is, and then replace this number with the quotient. Okay, and keep on doing this until this condition is satisfied. Then as soon as this condition will not be satisfied, it will come out of the loop. So let us run. So let us run this, and now we'll go here. So you see, it will print quotient every time it does this division. And as soon as it gets 1, so if you divide 1 by 5, the quotient you get is 0 and remainder you get is 1. So now since the quotient is equal to 0, it has stopped run. You, for fun, what you can do is that you can add a quotient, add a condition which will never be satisfied. And what you will see that this loop will just keep on running forever. And after some point you have to kill it, or else you won't be able to do anything else. This loop will keep running forever. These are called endless loops, right? So in this section, for this section, there is a fun playground. In this playground, what you can do is that given in any number, if I give a number, let's say 314, what you should be able to do is that you should use while loop to find the sum of the digits of this number. Whatever the digits are there in the number, you should find the sum. So for this number, what should be the sum of the digits? It should be 4 plus 1 plus 3 is equals to 8. Right. So you need to find a way. You should use the while loop here to find the sum of all these digits. So this might be a bit tricky, but do you guys want to try it out now, or should you try later? So maybe I should ask Harshil and Akshit that, because this will take some time. So what do you want? It means that if they are trying it out now, it would mean that we will cover a bit of less topics later on. Harshil and Akshit.
I guess we can give this question as a homework question and can put the solution
Continue with
after.
it.
We can continue the meet.
Yeah, so the solutions are anyway available in internet, right? But the idea is that they try it out first. So I'll share these notebooks with you guys anyway, so you can just go through it and see if you can solve this, and later we can discuss. So I'll not show the solution to this because then it will be fun. So then the takeaway from this notebook is that, okay, if you want to add some branches in your code based on some conditions, you use the if else statement. If you want to loop, you have two options, for and while. So for loops you can use if you know how many times you have to loop, and while loop you should use when you don't know how many times you have to loop, but you know a condition after which you should stop the iteration, right? Yeah, so fine. So the next thing is even more important if you are going into scientific computing. So this is called functions. So for the moment, what we were writing, that we were writing codes, statements directly, for statements, while statements, if statements directly. What might happen is that you want to use that for loop multiple times in a single script, or multiple times from different scripts, that you want to use it multiple times, and you may want to use it parallel. So I am writing one script which will take use that for loop here, and Akshit is writing some script which will use the same for loop again, right? So how do we do it in this way, this fashion? Supposedly we are using the same hard disk and we have this for loop present there. How can we do it? For that we write functions, right? Functions, what they do is that they take a certain part of your code and put it inside an independent container, right? It becomes an independent entity which can be called by anyone and anywhere who is accessing that script, and they can use that function to do something, right? So this, what it does is that it makes your code shorter and it makes the code reusable. It allows many people to use the function concurrently, which means at the same time, and it makes the code modular, which means that you can divide the code into parts which does specific functions, right? You don't want the code to be a single we just written in one line after another and it can do a lot of things. What you want to do is that you can segregate these things into separate entities so that it will be useful and like easy to understand what piece of code does what. So now functions in Python are defined in this way. So def is the keyword. So if you write def space any name, it means it's a function. So the syntax is def space function name. Then you have a parenthesis and inside you have function arguments, which means that whatever the function wants to take in from the user or wherever it is called, you should supply something to the function. So then you have to write whatever the arguments are there. Right, a function can also have no arguments. Then it means that it does not require any arguments. So it depends on what the function does basically. So this colon is again very important. And then after that, you have to give the indentation so as to say that these things are inside the function. Then you say, ask the function to do a lot of stuff. And at the end, you might ask the function to return some value or many values all at once, right? Note that a function can also have no return values. This is also possible. So to illustrate this, I have chosen a very, very simple example. So we will just write a Python function which adds two numbers. So it takes two numbers as input from the user. It takes two numbers inside the function as function arguments. And it what it does is that it just adds both the numbers up, adds them up, and then it just returns whatever the result is. So see, the two numbers, I can declare it in this way. So this is a very funny way of declaring stuff in Python. This is not possible in C or C++. So you can declare two variables all at once. You can just write a comma b equals to 5 comma 2, which means a is equals to 5 and b equals to 2. And now you say that I'll call this function sum2 nums and I will pass this a and b there, and it will return me whatever value is the addition of them, and this addition whatever it returns I will store in this variable result, and at the end I will print result. So now what this function does, when it gets this a and b values, it will add them up and return whatever is the result. So let's see if this works out. So it gives result 5 plus 2 as 7, right, which is correct, we know. And now the question is that if I name this A and B, should these also be named A and B? No, these can be named anything. So whatever I say, I can just tell num1 and num2. Right. Only thing is that I should also make these num1 and num. Whatever is inside the function should have the same name as whatever you are having in the argument. But this can be A and B, doesn't matter. You see, the result won't change. So it is still 7. I ran it again, I'll run it again, and it is still 7. Doesn't matter. Right. So this is how you write simple functions in Python. Now to go more into functions, I'll quickly discuss a more important thing is something called lists. Right. So lists can contain multiple data of similar types or different types inside one single variable. Right. So this is very similar to array in C or C++. But the problem with array in C and C++ is that if it is an integer array, it can only store integer values. If it is a floating point array, it can only store floating point values. But in Python, this list, they can do, they can store all data types all at once in a single array. See, so I've created a sample list here, and lists are created like this inside third brackets or the square brackets. So I have first element of the list is dog, which is a string. Then we have an integer 4. Then we have a boolean true. And then we have a floating point number 7.25. Right. What I can do is that I can just print the entire list all at once. And I will also check what is the type of this variable sample list. See, so it just printed everything all at once, and it will give the type as list. Now there are many things we can do with list again. What we can do is that we can take out element of a list by specifying the index. So if we say index 2, what should be the value here? So this is 0, this is 1, and this is 2. So this should give me true. So element at index 2 of the list is true, which is correct. This is how it works. So if, for example, in MATLAB and stuff, this is 1, this is 2, this is 3. But in Python and C, this is 0, this is 1, this is 2. Right. Then list also has some function similar to string. So if you write sample list dot append and then give something, what it will do is that it will add whatever you gave here to the end of this list. So you see that after appending high at the end of the list, the new list has become dog 4 true 7.25 high. Okay. Now what you can do is that you can also delete a certain element from the list. So you can just say that which index element you want to be deleted, and you just say sample list dot pop. Pop means remove. Pop 1. Right. So I want to remove 0, 1, which is 4. I want to remove 4. So if I remove the element at index 1, then I am left with the list which does not contain 4. It's devoid of 4. It's dog true 7.25 high. Fine. So this is some functions which are available for a list data type similar to the strings. And for more information or for more methods, you can look here. So I have added the link here. You should be able to access. So next, what I'll do is that yes. Any doubt?
But when we execute the append function, it changes my original string. But how can we like ensure that my original string is not changed, list is not changed?
So if you are writing this sample list dot append,
Yeah.
right? So you are already specifying that this is for this list. So you want to change
Correct.
this list. That is why you are writing, right? So I guess this should work out. Just a minute. So let's say I don't want to change the sample list. I'll restart this kernel once. Yes. So this is my original list, right? Dog 4 true 7.25. And what I should do is that list 2 append. Let's see. I hope this works out. One way you can do is that you can just copy this list somewhere, and then you can just again do list 2 dot. See, so this is list 2, and let's just see if it changed sample list. Oh. Yes. So what it does is that basically if I write one list is equals to another list, what it will do is that it will copy the memory. Okay. It will not create a copy. Rather, what it will say that this list 2 now points to this sample list. So if I make any changes to list 2 there, what it will do is that it will also change whatever the original list was there, because I have said that whatever change is there, it should be reflected here, because this is just pointing to this. But here what I said, make a copy of sample list and then store it in this list. So this is not now pointing to the original list, but it's just a copy, right? It's just a copy. So if I make any changes to the copy now, you see that it has not changed the original list. Clear?
Yes, sir. Yeah.
Clear, right? So
Oh,
this is
yes,
how
sir.
you can also maintain the copy of one list and copy of the original, and make some changes to others, right?
Okay. Thank you.
Yeah, yeah. So you can play around with all these methods, which you find here, and that you can do later on. But what I'll do is that I'll quickly go into a functions example, more fun example, let's say. Here, what we will do is that we will write a Python function that can find the longest string in a list of strings. So see a list of strings I have created, which contains dog, cat, aeroplane, elephant, and Andromeda. And what I'll do is that I'll create a function which is named find longest string. This you can name anything. Okay, but it's good practice to name it in such a way that you should understand what it is trying to do. Right. So find longest string, and then it will receive the list of strings as an output, and it will say means initialize a variable length equals to 0, and then longest string you can initialize it to anything. Okay, doesn't matter. This will be changed later. Now see, this line should be new for you, right? What it does is that this for loop is a bit different. So instead of using range, what I have done is that I have used this function known as enumerate. What this does is that if you give enumerate a list, it will give you two outputs. One output is that it will give you what is the index of each position. So it will give you two variables. So this ITR will go from 0, 1, 2, 3, 4. And this string, what it will give you is that value, which is contained at this index ITR. So it will give you 0, comma dog, 0, 1, comma cat, 2, comma aeroplane, 3, comma elephant, and 4, comma Andromeda. This is how it does. See, so if I just print ITR comma string, this is how it does. 0 dog, 1 cat, 2 aeroplane, 3 elephant, 4 Andromeda. This is what enumerate does. So this makes our life a lot easier. Well, we don't have to access element. We don't have to know how long the list is. Those are also ways to do. And those are not very tricky to do. But this is something that I am teaching you extra. And this is very handy. It will come very handy later on. Right. So this is print ITR comma string. So I'll just delete it for now because it looks clumsy. So now the condition is that you use this function which is len, and give it any string, and it will tell you what is the length of that string. Right. For dog, it will give you 3. Cat, it will give you 3. For aeroplane, it will give you 5 plus 4, 9. Right. Like this. And what we will say is that whatever length we had here, 0. If the length of the current string, whatever we are wherever we are in this list, if the length of the current string is more than this length, then this make this the longest string. And we will do this for all the cases, and we will see that after some time it will see that the Andromeda is the longest string. So it will give you Andromeda. Okay, so there is one mistake here. Can anybody find out? So what it will do is that if let's say I removed Andromeda here, if I removed Andromeda, it will give elephant. Right. Now if I put elephant here before cat, right, if I put elephant here before cat, it will say that cat is the longest element, which is not true, right? Because I have made a mistake in writing the code. What I should do is that once I find the longest length, I should also make length is equals to the longest. This should give me the correct results. Now see, aeroplane is actually the longest string. So see, I made a mistake. Okay, and I was able to identify by counting the letters by my hand. So this is also known as debugging. These mistakes also you can make, and you should know where you could have made these mistakes just by looking at the output. This is the level of practice you want to get at, so that you are good with any language. These debugging skills will help you with any language. So this is one of the example that we can do uh, using list and functions and also some sort of string manipulations. So once this is done, right, so the next for homework, what you can do is that you can take this sample list and write a Python function which will take this list and tell you how many odd integers are there in the list. So the answer should be 9, 7, and 19, right? So you should have 3 odd integers. So your code should say that there are 3 odd integers. So try this out. Keep this as a homework. And the next part, which I actually didn't want to discuss in the first place, which is called classes and objects. This is maybe not very important if you're doing simple numerical analysis or stuff like that, or maybe data analysis also, because this is a bit of an advanced stuff. Reason did not want to go through this in the first place was that because it warrants a detailed discussion on something known as object-oriented program, right? And that is actually theory. You need to know a lot about the theory of object-oriented programming. What are the steps? What are the uh, concepts attached to object-oriented programming? If you don't know those, then it's a bit difficult to understand what classes and objects do. But anyway, I'll give you a very, very, very crude introduction to this. So this is called, so a class is basically a blueprint of a container. It's a blueprint of a container. Imagine it as your school bag or something, which has different compartments, and those compartments can store different types of things like phone, power bank, water bottle, blah blah. So different types of things in this case means different type of data, string, integer, then it can store floating point, anything, right? It can also store list inside a class. So class inside this container. So this container which you can generate from the blueprint which is given in the class, this container is known as object. So you write a class which defines any object which looks like this, but the values that are contained inside each object can be different, right? So I'll show you an example what I mean by that. So class is written in this fashion. So class, and then you write the name of a class, which is name of the class, which is class animal, right? So I wrote class animal, and then you have to give the data members. So the data members I want are species. So I'll just initialize with something empty, right? Any data that I want will be given by the user. So species is this, age is 0, color is also nothing as of now. Then we have one very important function which is also called as the constructor. This constructor, what it does, based on the values that we specify or whatever the values we give here, it will initialize the container for you. It will add some values to this data or these variables inside the container for you. So if you create a object named dog, then you can add species as dog, age as let's say some 3, 4, 5, and color should be let's say white, black, brown, whatever, right? So this is how you can do. And what you should do is that what one important thing to note here is that this self thing, right? So self, what it does is that self talks about the current object. So if I am telling that self dot species, it means that the object that we are creating now using this constructor, for this object, the species value I want to change. So if you just write species equals to species, it will not work. You have to write self dot species, which means for the object I am creating now, the container I am creating now, for this container, I want to add, means I want this species value for this container to be this. Similarly, for age, I can add something. For color, I can add something. And then I can add more functions inside the class, which will do certain things that I have specified. For example, all these functions here, what they do is that they get this species. which means if you call this function, they will print whatever the species is contained here. It will all, for get age, it will print the age. For get color, it will print the color. Right. So here are many things which I could talk about. Class object is itself a course. Right. So it is not possible to cover all these things in 10-15 minutes. So for this, I'll just show you a quick tour of how we can create multiple animals or objects like here per se. So I will create a dog object here, and I will call, how I will create, I'll call the class, and I'll pass the species as dog, age as 4 and color as brown. And then I'll call the class, whatever object I created, dog obj, and I will call the functions which are inside this object, get species, get age, get color. So if I run all these things, see, it will give you dog, 4 and brown. Similarly, we can create multiple such animals or objects from the same class blue. I don't need to write this class again and again, but what I can do is that I can create a cat obj by calling the same class and passing cat, age is 2 and color is gray, and it will give you cat 2 gray. Right. A more detailed discussion on this requires we know stuff about object oriented programming, which I already said and I am telling repeatedly. But if you are really interested, what you can do, YouTube lectures are fine, it's fine. But if you want to read a book which has some hands-on examples which you can play around with for all of Python, basically, not just class object, but these 3 books will help you, right? These are the 3 books that I could find, and this will help you a lot. So once you get this notebook, you can just go ahead and download this book from wherever you want, and then you can just go through it. So seeing that we have around 15 minutes, right? So what I'll do is that, so here I don't have any playground for it, right, for class and object, because it's already very complicated, and I don't think I have given a very uh, detailed introduction to ask anything from you to practice. But I want that if you really think class object can help you, you should go and read those books. For the next part, what I'll do is that I'll just quickly give you an introduction of these 2 libraries, which are very, very useful if you are in engineering disciplines, right? If you want to do numerical analysis, if you want to solve ODEs, PDEs, means ordinary differential equation, partial differential equations, or you want to do some linear algebra calculations, Fourier transforms, blah, 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 then these 2 libraries can help you a lot. So these 2 libraries are known as NumPy and the Matplotlib, and they are very, very famous now. They are very famous. So I'll start with NumPy first. So NumPy is a numerical library, and that it gives access to uh, a lot of mathematical functions. Right. So it gives you access to a lot of mathematical functions. It allows you to manipulate arrays. It allows you to create arrays in the first place, which are very similar to C and C++. So there you cannot store strings and uh, other things, strings and boolean with floats or integer. So if it is integer, it should always be integer. It is a float, everything should be float inside. So you can create those sort of arrays. You can do large scale linear algebra calculations like matrix multiplication, dot product, cross product, and blah blah. The most useful of all of this thing is that this NumPy is actually written in C, and this library is extremely fast and is a must-have tool for data analysis and scientific computing. And also, it is written in C, but you can use the interface in Python, which means you are writing codes in Python, but you are getting performance which is close to C and C++. Right. So it is extremely fast and extremely easy to use. And also, if you have done MATLAB before ever in your life, then the API, the application user programmer interface, everything is very similar to MATLAB. So first, as usual with any of the so just give me 1 minute. I'm getting a call. Yeah. So first, as with any type of modules, what we do is that we import, right? So previously what I did was I said just import math, right? But here we can do more fun things because NumPy is a big word maybe, and people usually compress it to NP. So we will write import NumPy as NP so that if we want to call NumPy ever, we will just use NP, right? That is how it is. We just made an alias for NumPy. So now first what we will do is that we will just create some arrays with NumPy. So first array that we'll create is an array of size 5 which only contains 0. And how we will create it's very simple. 0 array is equals to numpy or np dot zeros, and what is the size of the array you want. So you will see that it just creates array of size 5 and it only contains 0. Right. For creating an array of ones with size 5, you should do np dot ones. Sorry for the typo. So now you see it will only give you 1, 1, 1, 1, 1. Similarly, what you can also do is that you can do random array, right? You can just say np dot random 5. So it will create any number which is smaller than 1 and random number. It will just choose on its own, right? And the total size of the array will be 5 and it will have 5 random numbers. So you can see here we have 5 random numbers randomly generated. So if I run it again, they will change. They will keep changing. Right. And another thing is that we can use linear array. So what we will do is that we will make an array from 1 to 5. Make sure means know this that this is inclusive of 5, unlike of range. So if we are doing range, it would have done 1, 2, 3, 4, not 5. 5 will be excluded. But here it will include 5. So it will be 1, 2, 3, 4, 5. And how many numbers it should generate? It is 5. And you see that it has generated 1, 2, 3, 4, 5. So this come very handy when you are working with large arrays and you want to do manipulation, you want to do calculations and stuff. These come in very handy. And I'll show you some examples now. So NumPy also has a lot of mathematical functions, right? So I picked out trigonometric functions because they are very easy. And fun thing about NumPy is that you can actually take one array and put it inside the trigonometric function, and it will apply the trigonometric function to each element of that array and give you the result in a new array, right? So for example, I have angles which is created linearly from 0 to pi, which means 0 to 180 degree. So I print the angles here. See, in 180 in degrees I have printed the angles are 0, 30, 60, 90, 120, 150, 180. And if I pass all these angles into sine, np dot sine angles, np dot cos angles, and np dot tan angles, you'll see that they will generate the things that we, the sine theta, cos theta, and tan theta, the way we know. So see, for sine, I'll show that we have for 0, we have gotten 0. This means 5 into 10 to the power minus 1, which means 0.5, which is 1.5. This is 1 by root 2. This is sine 90 is 1. So sine 135 should again be 1 by root 2. Sine 150 is again 0.5 and sine 180 is 0. So you see that it's 1 into 10 to the power minus 16, which is a very small number, and it's actually 0. Similarly, you can do for cosine, and for tan, you see that tan for the funniest thing is 90. So we know that tan 90 is infinity, right? But in the computer, instead of giving you infinity, it is giving you a very, very large number, which has nothing to do with infinity or such, but it is very, very large, which is the computer limit of infinity. Okay, so this number is sort of computer limit of infinity, the maximum number computer can give you. That is why it is giving you a very large number, which is tends to infinity, you can say. So that is how things work with NumPy. And you can use these functions into any number of arrays and it will give you nice results. So the entire functions of NumPy and the documentation, you should look here. It's a very mature and still being developed. It's very mature library. It's still being developed. It's constantly supported, and you will find any problems, solution to any problems you face in Stack Overflow or Geeks for Geeks. So that is how you can learn NumPy really. But what I'll try to demonstrate is that why use NumPy? What are the advantages? So what we will do is that we will do matrix multiplication using a for loop and NumPy, and we'll see which one is easier. So let us first declare two arrays, two matrix 1 and matrix 2, and I'll just print this matrices. See, this is matrix 1, 1 2 3 4 5 6 7 8 9, and then we have 7 8 9 4 5 6 1 2 3. What we will do is that we will use the for loop to do the matrix multiplication. So this is the code that can do it. So I will not go through this code because it might take some time to understand. But this is a code. I will encourage if you go look at this code once and try to write it on your own, because this is very, very important if you are doing scientific computing. So matrix multiplication, if you do, you will get some result for the folder, which we got here. For NumPy, you don't have to do all this. What you do is that you just say np.matmul, which is matrix multiplication. Matmul, and you just pass mat1 and mat, the matrix 1 and the matrix 2. And if you run this, you see that you have exactly the same result. So to show that this result is exactly same, what we can do, we can just subtract this from this, and you'll see that it's 0 0 0, which means these are the exact same result. Now you see, you just did it in one line, and here you have to do a logic. Means you have to apply some logic, and it will take at least more than one line. Now this is for a very simple example. Matrix multiplication is still simple, and for this small now matrix it doesn't matter, but if the matrix is large, or if you have more complicated logic, for example eigenvalue, finding the eigenvalue of a matrix, then NumPy will just do it in one line. You just write numpy.linalg.ix, and it will give you the eigenvalues of a matrix. But for if you want to write it, it will be a big code, and it will be very difficult logic, and it will not be as fast as NumPy, right? So to demonstrate the speed of NumPy, I have also taken out one example where what we will do is that we will take an array which has 100,000 elements or 1 lakh elements, and we will take exponential of the entire array. Okay, and we will see which takes least amount of time and how fast is NumPy actually. So for the for loop part, what we will do, for loop type approach, we'll import math, and then we'll say that define exponential using for. We give an input array and we have a result array, and what we will do is that for every element in that array, we will go about and we will just take math.exponential of that array element and store it in result, right? If you do that, so we generate an array which is 0 to 1, and it has 100,000 elements, and the result array is exactly same as array. That is why I write like, but it will contain only 0. So it's np.zeros like arr, which is very easy thing to understand. Now we will use something which is called percentage time it. This you may not have in your computers, but I have just taken it just to show you how much time it takes. So let us run this. Okay, now what we will do is that we will first see how much time is taken by for loop approach. Let us see. So it will run and it will give me the average time taken for this method to do the exponential of the entire array. So how much time did it take? It took 13 milliseconds, right? Now let us do it for NumPy. And it took 377 microseconds. So if we see how fast it was, 13 by, so it's, since it's milliseconds, we should multiply by 1000, and then we should divide it by 377. So NumPy is in this case 34 times faster compared to what the for loop approach did. So if you keep making this array large and large, you will see that NumPy will still be more and more fast compared to the for loop approach. The result is because whatever exponential it is taking, the NumPy is taking the exponential, it is taking in C. It's written in C, which is why it's very fast. So basically you lose less time because you are writing in Python just by using something like NumPy. But if you use math, which is written in Python, it will take lot of time. So this is one of the useful use cases of NumPy. And I'll urge that if you are going into doing a course on numerical analysis and stuff, please implement all those routines, Newton-Raphson second method, bisection method, and integrals, numerical integration, and every stuff. Please do all those uh, yourself in Python. Write it using NumPy. NumPy also has numerical integration tools. Use NumPy's integration tools, write it on your own and see which one is faster, which one is better. And then you will learn how NumPy works and what are the possibilities. The last thing I want to discuss is matplotlib. So this is a library that allows you to do plots, make plots, right? It's a visualization library and it can make you 2D plots, 3D plots, 1D plots, contours, surfaces, and so on. And it's very easy to use with NumPy data, and the application interface is again similar to MATLAB. So what we do is that we import the matplotlib.pyplot. This is a sub module of matplotlib as PLT. See, matplotlib is a huge package, right? So I also don't know everything about matplotlib. Whatever I use, whichever is useful to me, I have learned all those things. So similarly, you will learn, but I'm just showing you some simple examples. So if you just import matplotlib.pyplot as PLT, and the question is generate a
Sir,
graph. Yes.
some of the students have commitment around 9, so can we just discuss on some questions, then you can continue. Anyone have doubts or like that?
Okay. That works.
और जिनकी
So
कमिटमेंट्स है
I
वो थोड़े क्वेश्चन सेशंस के बाद जा सकते हो. रिकॉर्डिंग अवेलेबल हो जाएगी इसके बाद के सेशन के.
so if anyone has questions, then you can ask me. And either way, I think it will just take 5 minutes for me to wrap up.
So you can complete first. If it does not take much of the time, then you can complete first and then students can ask their queries.
So yeah, so it will take just 5 minutes. So I'll just take 5 more minutes.
Okay, complete.
So for the
You can complete.
yeah, okay, thanks. Yeah. So the first question that I wanted to address was generate a graph of y equal to x, which is simple. So what you do is that you use the linspace command to generate an array of x, and you create another array where you say y equals to x, and you just say plt dot plot x comma y, and you just put labels x comma y. These are all beautification things, and plt dot show command is used to show the graph. So you'll see that it will generate a graph of y equal to x. This will take some. Yeah. See, so it generated a graph y equals to x. So similarly, as an exercise, what you can do is that you can plot a graph of y equals to sine x. Another example that I wanted to give was a 2D contour. So let's say I want to create a contour of this function fxy, which is x square y square, from x 0 to 1 and y 0 to 1. What should I do? I should do x equals to linspace, y equals to linspace from 0 to 1, and I want 100 points in between. And this is something which is np.meshgrid. What it does is that, so these are one-dimensional arrays. These are one-dimensional arrays. What it does is that it combines two one-dimensional arrays to form a two-dimensional array, which will give you a checkerboard. So basically, instead of having x here and y here, you will have a grid of x comma y coordinates. So what I'll do is that after that I'll use some numpy commands, which you can see already very verbose. So power raise xm, the mesh to the power of 2 and y to the power of 2, and multiply the resulting together element by element, and you just plot it. So if you plot this here, you see that you have plotted a contour where we expect that 1 square multiplied by 1 square should be maximum, which is why this has the maximum value of 1, and others have decreasing value, and here you should have 0 comma 0. Here also you should have 0 comma 0 because it's 1 multiplied by 0 and 1 multiplied by 0. In similar way, what you can do is that you can make 2D contour of sine x exponential y, which I leave it to you as a homework. and you can try out some more things. So the documentation is here. You can make surface plots and many things using Matplotlib. So the other homework, that is something that you should do yourself, and I'm not asking you to do. Means I'm not forcing you to do, but I am giving you an advice. But whenever you do numerical analysis courses and stuff, try to implement all those things yourself, and then plot it using Matplotlib and see if you understand it geometrically, the results, right? So that is all for the content of the workshop. So now if you have any questions, you can go ahead and ask.
Nice.
Yes,
Hello.
go on.
Can you suggest some sources for solving ODs, PDs, and DAEs?
So what you should look at if you want to solve ODs, DAs, PDs, then you should look at this library, SciPy. This is similar to
Okay.
NumPy, just that it has more uh, functions, and it has some functions which can help you take Fourier transforms. It can help you integrate ODs to obtain the results. Right? It can help you solve boundary value problems, initial value problems. So SciPy is the website.
Okay.
So one of our professors from IIT Bombay has also contributed to SciPy. So it's very good, really very good. Okay. Yeah. So SciPy is one very good library. So if you are going to scientific computing, you should know NumPy, uh, Matplotlib, and SciPy. These three are the things that you have to know. Then you can tackle any problems that usually come around. So all the problems that we as chemical engineers, mechanical engineers, civil engineers face are mostly PDs or ODs, right? So you want to solve that, you should learn all these tools. There are more advanced things that we could have talked about in Python, but as you see, that 2 hours is not enough for all these things, right? So you will find nice lectures in YouTube and stuff, but if you are into reading and implementing stuff, you can read the books that I had suggested previously. And mostly coding, it's an experiential learning, right? So what you have to do is that just go ahead, make mistakes, go to Stack Overflow, see what mistakes you made, experiment, and you will learn. That is the best way of learning. So from these workshops, you will just get a head start. You have something to play around with, and then you have to expand upon that. Any more questions? Arun, are you asking some question?
मैं सप्ली नाही करे मैं सप्ली करतो ना माझून पाहू नका दुसरी कोणती कोणती आहे
See if you have any questions or not. If Vaishnavi, Harshil, and Akshit, you think that they don't have any more questions, then we can probably stop. So your call, really.
Hey guys, if you have any questions, you can ask. Else we can end the meeting as the time is 9 and we cross the time.
Okay. So then I guess we can wrap up, right?
Uh, Yes, sir. I think we can wrap up. So,
If
So,
anyone
thank,
has a doubt, maybe we can wrap up.
so what
thank you,
I'll do
Malyadeep sir,
just,
for this wonderful session.
yeah, no, basically, thank you to you for giving me the opportunity. What I'll do now is basically I'll just quickly share the notebooks in the WhatsApp group. Does that work?
Yes, sir. Yes.
Hello.
Yeah.
Yeah,
Yeah, yeah.
We
yeah.
can
So
share.
I'll just quickly share them. Uh, can you confirm that you have received those?
Um,
Yes, sir. We have received.
Yeah, great. Great. Then I guess it's okay. Then we should leave. And I was asking to, I had to ask one thing, if it is possible. Is it possible to get a feedback from the students? Do you think it's possible? Harshil, Vaishnavi, Akshay.
yes, maybe we can circulate a Google
We
form in the
can.
group and
Yes, yes.
students
We can.
can respond on that. It is possible actually.
Then it will be helpful for me actually. Because so I have not have had many teaching experience as such. So it will be helpful for me if you can give a feedback for.
Okay, we'll
Okay.
circulate the Google form by tonight, and then as the responses are covered, we'll share the reviews with.
Okay. Okay. Great. Great. Thanks. And then I guess we can leave, right? Yeah.
Thank you so much for
Yes,
Okay.
sir.
taking this
Thank
session.
you.
Thanks for
Thank you.
having
Thank you,
me.
Thank you.
sir. Bye.
Yeah. Bye.
Thank you, sir.
All of you guys, hopefully you like this session.
Thank you guys for attending session.
Okay, then.
Okay, now we can end the meeting.
Sir, we
Yes.
sir we have to use Python interpreter to use that files, right? That you have sent.
Yes, you
Yeah.
have to use that on like you can use VS Code or Jupyter Notebook to run that. Firstly, you have to save that file on your laptop
Okay,
in
sir.
the location. For that, you have to do the Jupyter Notebook setup.
Yeah. So I mean, you can do it on a Jupyter if you have VS Code, then VS Code, and if you have and Google Colab, of course.
Yes, sir, got it. Thank you, sir.
Yeah. If any doubts. Okay, then I guess we can end the meet. Harshil.
काम पडणार आहे घेतलं त्याला आवडत वांगेली भाजी आई गेली असलं ते बाहेर ह्याचे आत्ता घेऊन झाले मगापासून घेऊन तर ना हम्म. अरे